Welcome to Chapter 2 of the Adquio Web Interface course. In this chapter, we are going to see the variables, the devices and the modules, although we are not going to see them in that order, but we will see the modules first, then the devices and then the variables, and we are going to do this like this, because they have dependencies between them. We cannot see the variables without talking about the devices, and we cannot see the devices without talking about the modules. Therefore, we are going to see them in this order. As we mentioned in the previous chapter, modules are a kind of driver that devices need to be able to connect with the outside world. We are going to call module instance each of the connection configurations with a group of devices. Each of these instances can communicate with one or more devices, always of the same protocol. Let's give an example to understand this a little better. For example, a Modbus 485 port can be registered only once in a port. That is, if an Adquio has 485 ports, we can only register a 485 module on port 1. The same would happen with BACnet. And for example, in the case of IP devices, we could only register one device on the same destination IP. That is, for a remote IP, we cannot register several modules. In the current screen, we are seeing is a list of modules of an Adquio that is in operation. We see that in the left column, they have a green indicator, which in this case, would be indicating that the module is in service. In case they have a black indicator, it indicates that the module is deactivated. In this case, we are not going to start it, because it is a port that has nothing connected. I have simply created it as an example. Since we are here, we are going to take advantage to see this menu. We see that we have 4 options. The delete option would eliminate this module, but be careful, because if we have devices that depend on it, it will not allow it. In this case we will see what happens. We have the Modbus RS4852 module, and I have created a device that depends on it. So, when deleting it, it will give us an error message, and it will tell us that there is a device with this associated module, therefore, does not allow us to remove it. Then, we have the confidence that this is proven, and that it will not allow us to do something wrong. We can start the module. We can stop the module. We can restart it. After creating a module, it is necessary to start it, so that the devices that depend on it work. If we deactivate a module, we are deactivating all the activity of that port to which it is associated. It is useful if we want to change a cable, if we want to disconnect the bus, and make sure that there is no traffic at that moment through it, etc. And restart the module, because if in any case, we have a communication problem, and we want to try to restart the module to see if communication is restored, before ruling out a wiring problem, we could use this option. We are then going to enter the addition of a module. The first thing we must know is that the addition of each module, depending on the type, will be totally different, since it will request the data for the type of connection that we have defined. In the first field, in this case, we have many connections we can have. Modbus RTU through ports 485. Modbus TCP through network ports. BACnet IP through local network using Ethernet ports, and that includes all the Adquio. BACnet MSTP, which would also be through 485 ports. And then, we have other protocols, such as hardware stats, which are simply statistics of Adquio's own hardware. CPU temperature. Storage occupation. Memory occupation. Etc. And then, there are some others that we will not see in this training, because they are for very specific cases. Further, we can comment on the access people counter, because in some entry on our blog, we have already mentioned this feature, and that is that Adquio can connect with cameras of this type, and count the people entering and leaving a building, and therefore, give the occupation, but it is not what concerns us now. We will see the Modbus RTU and Modbus TCP modules in a separate chapter, and the BACnet IP, MSTP modules, we will also see them in a separate chapter, because they have enough content to dedicate a lesson only to them. Therefore, we are not going to see in this chapter of the course. Let's go remote. We give it a code. We simply indicate in which IP address it is, on which port, and what its username and password. We would already be. In this way we would have a remote Adquio connected. And finally, we are going to see a slightly peculiar module, that is going to be the memory module. We are going to call it variables, and we see that it does not have any more parameters. What are these modules for? Adquio allows not only to define virtual variables, that we have already mentioned in some cases, but also virtual devices, as all devices need a module. This is where we create that module. A typical use case would be, I am going to create a module of variables, to in turn create a device also of variables, and the device is the one that contains all the variables that I want to be persistent within my programming, persistent in terms of the current programming session, although I can also define variables. Later we will see it within that device, that are persistent in time, that although Adquio turns off, when it starts up again, its value will continue to be maintained. I am getting a little ahead of myself. Just that, we know that the creation of memory type modules would be for this type of example. Very well, and with this, we have finished looking at the modules part, so now, we go with devices. The first thing we see is that, on the left, they have a column with some colored indicators. If the indicator is green, it indicates that this device is working properly, normal way. If the indicator is black, it indicates that the device is stopped. If the indicator is yellow, it means that the device is starting at that moment. If the indicator is red, it means that the device is out of service and that although it is properly configured, it cannot be consulted. We are in an error state. We are going to create a new device. In this case, we are going to create a memory type device, because, as we mentioned, in the case of modules, we will dedicate a special class to Modbus devices RTU and TCP, and another to the BACnet MSTP and IP devices. Therefore, we select memory, and we are going to call it vars, because it will store my programming variables, and I'm going to call it internal variables. Well, we could give it a description that is a text for as long as we want, and as on other occasions, we can register sets of field name and value of the field. In the case of a memory device, it does not make much sense, but imagine a device that if it is a physical device, here we could put the serial number, and here, the serial number of the device. In this way, we would have it associated and controlled within, from the Adquio interface itself. Reading interval, it is also for the devices, and it is, how often this device is read, in the case of a memory device, also does not make sense, because it is on demand when using that variable. Therefore, it would not be necessary to cover it, and as we can see, the module only lets me select vars, because I only have a memory type module created, and I have called it vars, therefore that's it. Very good, because with this, we would have already created a memory type device. As an example, the other type of device that we are going to see is remote Adquio. As you know, Adquio has its own communication protocol, which allows us to do distributed installations. Therefore, we could create a device that is not really a device, but is simply another Adquio, which is on the same network. As through the module we have already indicated which Adquio we mean here, all we have to do is tell it how we are going to call the device in our Adquio. We are going to call it, and we are going to put it. So, much better. Very well. Important part. Code the remote device within this Adquio to which we are going to connect. What code do we want to import this device? We want to import, well, we could put for example, statics, which are its internal statistics. With this and by selecting the corresponding module here, we would already have this device of this remote Adquio, available on our local device. Well, with this, we conclude for the moment the review of the devices part, although, I remind you again, that we will later see in depth the Modbus type devices, and the BACnet type devices, in the next lessons. We then, go with variables. To see an example of generic variables, we are going to use the memory device. In its lower part, we are going to create a new variable. We are going to do it this way, because it is the most generic to see the variables, but I must also tell you that in the cases of Modbus and BACnet device variables, the data that we are going to have here may be different and even greater. Well, we start as always. The code must be unique within this device, in this case memory, and we are going to call it, well, for example, temporary variable 1, we are going to tell it, what temporary. And, we are going to see typical characteristics of the variables, but, that in the case of memory devices, do not make much sense, because, they support everything, a device that is a memory variable, since obviously, it can be read and can always be written, but, let us know that at a general level, there are device variables that cannot be written, because, it is not reasonable. For example, a temperature probe is informing me of the temperature in a room, and, it is a read-only variable, because, I can tell the probe, what temperature should be in the room. Logically then, here, we could tell it that it does not support writing. If it were in this case, how is a memory type variable which supports both options? Because we would have everything marked. The reading interval, in the case of variables in memory, does not make sense either, because, these variables will be used, when the programmer needs it, when I invoked them, when I put memory.var1 in your code. In this case this variable will be accessed and its value will be obtained. It is not that we have to be consulting it every 5 seconds, as is usually done, with the variables that come through a bus. What types is the variable? Since we have all these types in the most typical case, also of a memory variable, because, it could be of a generic type, that is proposed by default, but, we see that we have. If it is a Boolean, could be on-off, can be a percentage, can be a pressure, can be solar radiation, can be temperature, can be a digital output or a digital input, can be CO2 level, etc. We are going to tell you that it is generic, and the units the same, if we were in a temperature probe, because, we could say that they are degrees Celsius. In this case, it is not any of these, because, we are going to put it without units. Converters. This part is very important, and, we are going to look at it in depth. The converters allow us, that the values read by Adquio, from any device do not have to be the values with which, we are going to work afterwards within Adquio. This means that, if for example, we have a device, which is usually the usual in Modbus, which gives me a temperature, but, gives me multiplied by 100, or, by 1000, here, I will have the possibility to tell it, that I want to divide it %, because, that Modbus device works only with integers, so, to send me 22 degrees, it sends me 2200, so, with this, I already get that the variable that came from a Modbus device multiplied by 100, when dividing it by 100, we convert it into a value of already usual work. It is important to say, that here we can not only put a mathematical operation, but, we can give more as many times as we need, and go taking the result of the previous line, and taking it as the input value of the next line. Then, we have no limit for the operations that we can perform, and we are going to see below, that depending on the type of operator that we choose in this drop-down list, we can have parameters, okay? He is going to ask us for these positions. And, on the return of the conversion, which we see that it summarizes it for us here, as it divides the by 100, the value should be a type of variable, that admits decimals, as we are using a temperature, as an example, and suppose, it is a room temperature, it would not happen of the 40 to 50 degrees. We can choose, for example, a 32-bit decimal, because they will be small numbers. We will leave you next, a table with the ranges that support all the variables, that we have in this list to serve as a reference. We are going to leave you this table in PDF format in the description of this video, in case you need to use it as a reference in the future. Let's review all types of converters have here, because, they are many and in many cases seems to be unintuitive for names that have meaning each. Sum can add us to the variable received a specific value. Divide. We just see it asks us by how much we divide it. Multiply. Multiplies it by a constant. Round. Rounds the value with the indicated decimals. Celsius to Fahrenheit. Can you imagine it converts from degrees Celsius to degrees Fahrenheit to Celsius? Since it converts from degrees Fahrenheit to Celsius, like it is already intuitive. Nullif allows us to indicate a parameter, and if the value read from the variable corresponds to that parameter, it turns it into a null that will indicate that it is out of service. Sif plus a parameter shifts the bits to the right of a variable. Cast allows us to convert data types as two parameters: the source data type and the destination data type. For example, it would allow us to convert an integer into a flat. Cab32 and int32 cab is used for Modbus protocols and changes the order of the bytes. The following the same, the db64, the int64 db and float64 db is also used in Modbus, and changes the order in 2-byte blocks. Invert16 reverses the order in 2-byte blocks in a Modbus variable. Swap16 reverses the order of the bytes in each 2-byte block. EQ plus a parameter: if the value of the variable matches the indicated value, it is converted to 1, but to 0 are the initials of equal. NE if the value of the variable coincides with the indicated value, E, it is converted to 0, if not to 1 are the initials of not equal. LT if the value of the variable is less than the indicated value, it becomes a 1, and if it is not a 0 are the initials of less than. LE if the value of the variable is less than or equal to the indicated value, it converts it to 1, if not to 0, are the initials of less or equal. GT if the value of the variable is greater than the indicated value, it converts it to 1, and if not to 0, the letters off would be the initials great than. GE if the value of the variable is greater than or equal to the indicated value, it is converted to 1, if not to 0. All this is available in the Adquio help, in the devices section for consult when you need it. Mappings. In this case, since we are creating a generic variable, and especially also as in a memory variable, the mapping does not make much sense, but we are going to see it, because it is interesting, and so we already have it clear by the time we get to the Modbus type variables and BACnet. We don't have to repeat it. Imagine that we have a device that sent me a status, and the status is 012 in the manual of that device. I see that 0 is off, that 1 is on, and that 2 is auto. It will save it like this in JSON format, but this does not worry me, because every time I come here to edit them and I click here, it breaks it down for me, and makes me a form much more enjoyable, and much easier to understand and edit. With this, what we achieve is that whenever we work with a variable of this type, we imagine what we were commenting on about the state. When I get a value of 0, automatically Adquio everywhere, both in the lists where the columns with the values of the variables appear and programming level, I can set the value to 0 in that variable, or I can set the value off in that variable. It is more, when I have to manually modify the value of that variable, it will allow me to write the number, or it will put a drop-down with these 3 values for me to select between any of them, and obviously, if I select auto, it will send the device a 2. OK. Minima m value and maximum value. In some cases, these 2 values can be very important, because they will allow us to set the minimum and maximum value that a machine supports in this variable, and that the Adquio itself will takes care of never sending a value outside of those ranges. If we set a range here, for example, from 1 to 10, if we later want to put an 11 here from programming, the Adquio itself will generate an error, and will indicate that it cannot. In this way, if we in the specification of the protocol of a machine, we see that it has a range of supported values, we can copy them here, and in this way, we protect the machine to never send values outside these ranges. Null values. It would be the values of this variable separated by commas, which can indicate that this variable is not available. So, if I know I'm going to read from a device and the variable must have a value greater than 0, and in that reading, it receives a 0, I am going to tell it here that if I receive a 0, as it is not within the ranges that I know that device is going to return to me, this 0 is going to convert it to a null, and a null is that it does not, it could be read, it means that there is no value. We can put a default value. This is fine, because this would be a way to always initialize that variable from creation. We could say that this variable, by default, always has a 5, and from there any reading we do from programming, while not we modify it, it would have that value. Persistent. It is very interesting. It means that the variables that we save here, if they are marked as persistent when we turn off Adquio, and turn it on again, this variable still has the same value as when we turn it off, therefore, it survives between turning it on and off. Incremental auto. It would serve to create variables that each time we read them gives us an increased value of the previous one. If we read it once, it would give us a 1. If we read it again, it would give us a 2, and, if we read it a third time, it would give us a 3 and so on. Very good, because with this, we have finished the generic revision of variables. He reiterated again that we will specifically see the variables of Modbus and BACnet devices in the next 2 classes. With this, we have finished this chapter, in which we have seen the modules in depth, we have seen the devices, and we have just seen the variables. We are waiting for you in chapter 3.